You're welcome to the GMAETS 41's live stream mathematics class. You know, in those days past, when we are preparing for professional examinations, and then you would hear stuff like, we are burning the midnight candle, right? Yeah, for those of us that have to make use of candle to study, and then you hear something like, we are burning the midnight oil. So by now, guys, you people are meant to be burning the midnight candle, burning the midnight oil. Anyway, this period, I think life is a bit okay in terms of all this. You can burn the midnight NEPA for those that electricity company are still serving well. Okay. All right, so here the GMAETS 41 is on live once again in order to carry you guys through the aspect of some topics in mathematics as you prepare for your examinations, okay? So we are going to be looking at questions from differentiation, from integration. We're going to be looking at questions from matrices and determinant, likely as you may have seen on the broadcast that I sent out. So once again, I am using this opportunity to say welcome. We are looking at mathematics. And in this class, we are going to be giving attention to differentiation, integration, and matrices. Matrices and determinant. So we're going to give attention to a couple of questions. Yeah, good evening. You are all welcome. First to comment, Kim Bolu. Yeah, you can see your comments. Ruth Ado, you're welcome. Ngacha Angel, you're welcome. Good evening. Promise, good evening, welcome. And the rest of you, Obia Julu, good evening, sir. Kandu don't cause to, unlike no deal. Nah, I believe you, I agree with you. Imagine from my end, it's been terrible. Burning petrol, you know, all this while. But all the same, we will continue to manage. We'll continue to manage in order to do the needful now so as to benefit later in years to come. All right, so without wasting time, we'll be moving ahead straight to the business of this class. Please, before we start solving questions, first on differentiation, then followed by integration and matrices. As we move on, or kick off with differentiation, problems on differentiation, I really want to urge you, friends, okay? I want to urge you. It's an advice and then a way of encouraging you. Please make sure you slide through the GMAETS 41's Math 101, Math 102 playlist. There I have a couple of videos, special videos dedicated to the concept of differentiation, to the concept of integration, and also to matrices and determinant. Now for differentiation and integration, is that before any student goes into this topic, there is something which is a key secret you must familiarize with. And what is that? Standard derivatives. Standard derivatives. There are about 14 to 17 of them that a student is meant to know. But we are going to limit ourselves to the number of these functions and their standard derivatives or standard integrals that the exam you're preparing for is going to test you on. WAEC, apart from further math students, in general maths, they don't bother them on this topic. further math students, they will bother you on this. JAMB specifically asks questions on differentiation, integration, and matrices, as the case might be. So, if you've not learned standard derivative, please, at the end of this class, do well to go through the playlist on this channel, seek for Math 101 and 102, search for the video lesson on differentiation. The lessons are already arranged topic by topic, right? Differentiations and integration. Then you're expected to memorize their standards. Yes, memorize their standards. Then you can use them to solve questions. For now, we are going to kick off straight on by solving some questions so we can go and take some rest. Yeah. So I have these questions right away. We are going to look at under differentiation. We're starting with differentiation, okay? You are examining a JAMB, right? JAMB is, according to the scheme of work, you'll be tested on not more than 3 or 4 of the functions. 1 is polynomial function. 2 is trigonometric function. In that trig function, you'll be tested on sine, cos, then at most tan, if they choose to bother you on that. But sine, cos, major. Then exponential functions, they hardly bother you guys on that. They hardly. So in fact, I think these 3 functions, polynomial, which we refer to, of course, that is actually power rule. Power rule. But just for simplicity, we call these functions polynomial. However, if you move on deep into the concept of polynomial, you'll find out that, yeah, those functions are not completely polynomial. Some are polynomial, others do not follow the definition of polynomial. But all the same, no problem. We're going to still refer to those functions as polynomial. You know, those functions, they are given like this. Let me write functions here just as a quick preview. To help our ministry as we move on. You'll be tested on power rule functions. They are polynomial. When a function is given as y equal to f of x to the power of n, then if you have to get the dy dx is going to be equal to, you differentiate from what I call the major function, the power, because the power helps us to know that this guy is a power rule term or a polynomial term. So you use the power to multiply the base, which is our f of x. Go to the power and subtract 1. That's the first thing you do. Use the power, multiply the base, go to the power and subtract 1. Then times, differentiate this base, this function of x, which I call the minor function. Differentiate it with respect to x. Differentiate the minor function with respect to x. Good. So that's the standard you need to know. Like I said, you can learn more about this stuff I'm showing on the board now. I don't just want to go into solving questions directly. I should have done that. But at least to give you just a little summary. Okay, now trigonometric function, you can be given y equal to sine f of x. Sine of a function of x. Your dy dx is equal to differentiate that. I usually differentiate the minor function, which I refer to as the function of x, differentiate it with respect to x, differentiate the minor function with respect to x, then times, go on and differentiate sine, which is the major function. This sine helps us to know that this is a trigonometric function, so that's the major guy. If you differentiate sine, it will change to cos. Take note of that. Differentiate sine, you get cos. Then in front of the cos, you write the original minor function. Then we have y equal to cos f of x, another function you can be tested on. The dy dx is simply equal to differentiate the minor function once again. You see, the minor function can be anything, so you wait for the exam questions, right? But as we solve questions, you're going to say that whatever the minor function is, you differentiate it. At this point, we don't know what f of x is. So you wait when questions are given, what is in front of that guy is your f of x. So you differentiate it, then times differentiate the major function, which is cos. Cos is the major here because it helps us to know that this is a trigonometric function. If you differentiate cos, you're going to get minus sine. So it changes to minus sine. Okay? Then once you change this cos to minus sine, because minus sine is a derivative of cos. In front of the sine, you write the original minor function. In mathematics, you are told that two signs do not follow each other, two mathematical operations. So permit me to put this in brackets, okay? Even though I could have left it. All right, number 4, y equal to tan f of x. Chances of your seeing any question on tan is very low anyway. For those going for JAMB, take note, WAEC, you can be tested on this. For those who are sitting for the math. Differentiating, once again, differentiate the minor function d dx of the minor function f of x. Whatever the minor function is, you differentiate it. So don't worry, wait until we solve questions. We will know what the minor function is. Then differentiate tan, the major function. If you differentiate tan, it changes to square sec. Written like this, square sec. Then in front of that square sec, write the original minor function. If you look at function number 2, 3, 4, they have this pattern they are following. Okay? So just for you to know, if you differentiate sine, you get cos. Differentiate cos, you get minus sine. Differentiate tan, you get square sec. Well, like I said, the chances of your seeing exponential function is very, in fact, I don't think I've seen such for JAMB students. But for the sake of just, okay, let's just do that. I'm going to write it, exponential f of x. Exponential, then on top, it carries that power, f of x, which is the minor function. The dy dx is simply equal to differentiate the minor function. All right, then times standard derivative of the major function. The major function is exponential. If you differentiate exponential, you will still get exponential. Then in front of it, as power, you write the original minor function, f of x. Then permit me to introduce the last one. This is natural logarithm. You are given this function y equal to ln f of x. In your calculator, you can find this function ln. It actually goes as inverse of exponential. Ln f of x, that ln is a mathematical function. So if you want to differentiate, what do? Once again, you follow the same pattern. Differentiate with respect to x, whatever the minor function is. And like I said, wait for your examiner to give you a question, then you know what the minor function is. Then times standard derivative of ln. If you differentiate the major function here, ln, you will get 1 over. That's the standard derivative of ln, 1 over. The question now is over what? Always what is in front of that major function. That is the original minor. If you look at, like I said, 2, 3, 4, 5, 6, there's a pattern they follow. Differentiate what you call the minor. Like I said, don't bother about the minor. Once you pick questions, you'll understand that better. Differentiate whatever the minor is. Then times, you will go and differentiate the major function. And like I used to tell students, somebody asks you, you said if you differentiate sine, you get cos. How did you get it? Tell the person to go and sleep. It's not the person's business. You know why? Most of the exams we sit for now, especially professional exams that usually use the CBT format. Nobody is interested in your knowing how derivative of sine changes to cos. That's the truth. However, it's important for you to know that we did not just wake up and say if you differentiate sine, you get cos. No. If you differentiate cos, you get minus sine. You differentiate tan, you get square sec. You differentiate exponential, you still get exponential. You differentiate the major function here called ln, you get 1 over. 1 over what is in front of it. We didn't just wake up to say these are what we are going to get. All of them, they have a method of deriving them. And we use a formula in mathematics called the first principle under differentiation. Let me write the first principle on the board. You are expected to cram, to memorize that first principle, yes. Because for the exam you are going for CBT, your examiner can ask you which of the following is the first principle formula. If I give you y to be equal to f of x, according to first principle, dy dx, that formula we call first principle, is equal to limit as delta x tends to 0 of f of x plus delta x, get something like this, then minus f of x. Divide everything by delta x. Anyway, no need of putting this in brackets. So this is the formula called the first principle. How we apply it for now, I will use the word, it is beyond our scope in what you need to know for the exam you are going for. So you don't need to bother yourself about that, JAMB student. And any other student going for a CBT exam, an exam where the question is all about you're giving options to select. No examiner will give you any question and compel you, force you to use this to solve it in differentiation. It's only when the exam you're taking under differentiation is theory, then you can be given a question and you are asked solve using the first principle. Just cram this formula. The highest your examiner can ask you in your JAMB is simply which of the following is the first principle. All right, so having said this, I've given the breakdown. We are going to move on. So bring the camera close. Okay. Let me see. Trying to ensure that nothing cuts off. So let's see. Let's see. I think it's okay. You manage this. Trying to be careful so that nothing will cut off from the board. All right. I think the adjustment of the camera is okay. So, network, please, so allow us to rest. Kimbolu is complaining. So, network, it's really too early to start misbehaving. Please don't, huh? Allow us to have a wonderful time. So, dear friends, you're expected to memorize these standards. We call them standard derivatives. Like I said, there are about 17 of them. A student is expected to learn, especially if that student has gone to advanced level, say in 100 level. For my students, university students, the Zekites, okay, those in Uni Abuja and other students from other schools that I offer service to, in your second semester work, you will need this. This is just a little of the more you're expected to know. Take note of that. However, since I'm focusing on the on JAMB and WAEC in this particular live stream, I am limiting the number of functions you are meant to know to these 6. And in fact, I can still limit it more. I can still reduce them more. I guess up to the first 3 are the ones that JAMB would usually test you on. Even WAEC, all right, O-level, that is, what is that even called? O-level exams, right? O-level school start exams, WAEC, NECO, in their further maths, most times they don't go beyond this first 4 or so. All right, let's pick our questions now and deal with. Like I said, you can memorize this. You can learn further, to get a full idea about this at the end of the class. Just slide through to the GMAETS 41s, Math 101 and 102 playlist on this channel. And then scroll through, you would see what's dedicated to this standard derivative. Finish your words on the board. I'm going to wipe them and then we pick questions to solve. Let us take our first question here. But should I go to question directly, or maybe let me give you something more so that I know I am done with all this, so that once we start solving question, you'll be following. Rules of differentiation. Let me just write that. Rules of differentiation. Rules of differentiation. Rules of differentiation. You will be told that there are 4 rules of differentiation, but honestly, you see, I don't like teaching and or learning in a way that it will stress me, as the case might be. 4 rules of differentiation. I always tell students, for me, there are 2 major rules. The other 2 rules are, to me, they are not rules per se. They are just a procedure. I don't know what to refer to them. We have that which we call sum and product rule. There is no big deal about that. So that's off for me. We have the one we call chain rule. Chain rule is one of the most important rule of differentiation. You don't joke with that. However, from the GMAETS 41, we will joke with it. Take note of what I've said. Chain rule is the most important. As a matter of fact, that's the main thing you do. That you have to differentiate this. All this stuff we did here, that you are differentiating. This is how you differentiate, apart from using first principle. The main thing that guides us in it is chain rule. So you don't joke with it. However, the GMAETS is telling you that we are going to play with it. With this standard I gave to you, you don't need chain rule. Yeah, at least. And the truth is obvious. for JAMB exam you are going for any objective examination as the case might be, chain rule is not necessary. The major minor concepts from the GMAETS 41 solves the problem for you. For that reason, chain rule as another rule of differentiation, I usually drop it. But you can learn more about it, slide through to the playlist, mathematics playlist, okay, and can get the full idea of chain rule. But for CBT exams, it's a waste of time. So the main rules we have for me when I deal with differentiation is product rule and quotient rule. Now for product rule, we have this. Let me write the formula on the board. Product rule. If you are given y to be equal to uv, then dy dx is equal to, in fact, okay, no problem. Keep one of them constant. I'll keep u constant, then differentiate v times dv. Differentiate v with respect to x. Then plus, reverse the process. Keep v constant, and then differentiate u, du dx. Please, don't go cramming anything here. Which one is u? Which one is not u? Which is v? Which one is not v? You don't really need it. By the time I am done with what I'm going to teach you, this thing is just very simple. Understand the rule, and that's all. These are two things. They are being multiplied. That's the meaning of product. And I say you should differentiate it. Keep this one constant. Differentiate this blue marker. Multiply both of them together. Then plus, next, reverse the process. Which means you are keeping this black marker. You are keeping this one constant now. And then differentiating this black marker. Multiply them. That is what this is all about. So I don't advise students going to cram this. If you're giving y equal to uv, the y dx is u times the v dx plus v is a waste of time. Second rule, quotient rule. Quotient rule. That is applied when two functions are given and they are being divided. So you have u over v. Because these guys are being divided is in quotient form, division form. To get your dy dx, it is equal to, in this case, you must follow the pattern. First, keep the denominator constant. It's a must. Then differentiate the numerator. Unlike this case, that is different from this product rule. This product rule, you can keep any one of them constant first. Now in this case, I can decide to keep v constant, differentiate u first. But in this case of product, you are restricted. You must keep v constant first. And then differentiate u with respect to x, that's the numerator. Minus, reverse the process. Keep u constant now, that's the numerator. And then differentiate the denominator with respect to x. Once you have done this, divide everything by square of the denominator. So once again, understand the rule and what is the rule all about. I have something like this. This is the numerator, this is the denominator. Simply, keep denominator constant times differentiate the numerator. Then put minus, reverse the process now. Keep the numerator constant times differentiate the denominator. Once you're done with this, divide everything you get by square of the denominator. So that is quotient rule for you. That is quotient rule for you. So with this, we are done with differentiation as the case might be in terms of the things you need to know. What we are now going to do is to pick questions and solve. What we are now going to do is to pick questions and do what? Solve. When you understand the principle of differentiation, see, this guy is 1 plus 1. Is what? 1 plus 1, and that is the truth. Please don't doubt it. Listen, let me tell you guys something, okay? You know you're my friends, and I just have to tell you the truth, just like the truth is. If anybody tells you that calculus is difficult, right? Tell the person that the person does not understand calculus. Because the truth is that this aspect of mathematics, differentiation and integration called calculus, it's simpler than other aspects of mathematics. Yeah, that's the truth. For example, the exam you're going for, like for JAMB now, if not for anything at this level, and even in 100 level, in 200 level, calculus is very simple. before you go into deeper aspect of calculus, even it will take up to a very greater higher level. And even at that higher level, at that very higher level, the stuffs you meet where you build on these bases are the things that will guide you in whatever you think is the most highest form of this calculus of a thing. So you have no reason to be scared of calculus. You're going to find out yourself. These are just like guideline formulas, and before you know, you solve them. Let's take our very first question. No time. I'm going to wipe this from the board. Copy that. You can screenshot so that I'll pick the very first question for us to solve. I hope you're done. Please remember to share the link of this particular live stream class in progress. Share it to your friends. Those who are sitting for this exam, if you are in 100 level, share it to your mates. You guys need this. My dear friends in Unizik, kicking off from 28th of this month, April, you are starting second semester live. Math 102, don't play. Don't joke with it. Anyway, I got you covered. I am GMAETS 41. I got you covered. Register with the GMAETS 41. Identify with this platform. Join our classes, both physical classes that hold on campus in Unizik. You can also join our online classes. And I'll make these stuffs 1+1 for you, because the truth is they are actually 1+1. I don't know what you think about it, but they're 1+1. That's the truth. And you have to believe me. You have to believe me. You have to. I'm saying this because when you guys resume, it's possible. Some of you are already scared of calculus. Now, some people will take advantage of that because you're naive, you are inexperienced in this. You don't know that calculus is really very simple, simpler than the Math 101 you did last semester, and simpler than any math you've done. But because there is this idea, people think that calculus or differentiation integration is difficult. People are kind of scared. They don't want to go into it. Anyway, I don't blame people, especially some educators who take this, because they even present this in a way that makes it seem as if it is difficult. And one of the major problems is this idea of using chain rule. Before you know, let u be equal to this, especially when you enter what is called function of function. But like I said, you don't need chain rule at your level of study and what you're dealing with. Yeah. So don't be intimidated by whatever anybody tells you. Like I said, if anyone tells you that calculus is difficult, tell the person you don't understand math. Now we have our very first question here we are going to solve. Question number 1. If y equal to 3t cubed plus 2t squared minus 7t plus 3, if y is equal to this, find dy dt. Find dy dt. Then we have the options there, right? The options there. Find dy dt at, okay, continues, at t equal to -1. Find dy dt at t equal to -1. We have the options there provided. Option A, -1. Option B, 1. Option C, -2. Option D, 2. Now look at, you are asked to find dy dt. Why? You are differentiating y with respect to t. You want to know how the changes in t will affect y. Because look at the thing given, this is the function given to you. Y depends on t. You can see that y is equal to something that contains t. So we can say that y depends on t. If anything happens to t, it will affect y. So how does changes in t affect y? That is what we are trying to find out. We are to get that change. We are to get how that change in t affects y. We are to get it at the value t equal to -1. If y was equal to 3, maybe let's say something that contains x here. We'll be looking for dy dx at x equal to -1. All right, solution. This function, first, you have to identify it. Is it polynomial, power rule stuff? Is it trigonometry, where you have sine, cos, tan? Is it exponential, where you have e raised to power something? Is it ln, logarithmic function, natural log? Which one of the functions do you think this guy is? From what I listed, you agree with me that this is function number 1, where you have something like f of x raised to power n. You would notice that each of these has a base that depends on an alphabet, and that alphabet there is t. Then it has a number as power. Anytime you have a variable, something about alphabet as base, and then it has a power number, that function is dealt with using power rule, because we model it as a polynomial function. Polynomial is when you have a base, alphabet stuff as base, and then it carries number as power. All right, so having said that, if y is equal to this and you are asking me to find dy dt, I'll simply come to this and then start differentiating. Remember, it's very simple. Use the power, multiply the base, go to the power -1. That is the first thing you do. So we do that to this. 3 times 3 will give you 9t, then go to the power 3 and subtract 1, -1. If you subtract 1 from 3, you will get 2. You know, there was something I did. For that first function. You can check back later, or if you copied it down into your notes, you can check that to differentiate polynomial function, you use the power to multiply the minor function, which is the f of x there, then go to the power and subtract 1, and then times differentiate that minor function with respect to x. Let me remind you, y is equal to f of x. Permit me to write it as f of t, since in this case y depends on t. You can use any alphabet you want, the choice is yours. So dy dx, I told you, is equal to use the power to multiply the base times the base, then go to the power and -1. Then I went ahead to do times differentiate that base, which is the minor function, with respect to, okay, this time it will be with respect to t. To be with respect to t, not x. So I have done this part. Look at it. This part where I use the power to multiply the base and then subtracted 1 from the power. I have done it for this guy. It is left with this part. But hey, for this particular question, I won't do this part. I won't. It's not necessary. There is a reason for that. Let me quickly show you. Our f of t is the base. That base that contains the alphabet we are differentiating. And here, if you look at that f of t is this one, for this particular one that I've differentiated. That f of t is just this t alone. Just look at it. That base that contains the variable you are differentiating. Now, if you look at this, this is just t. Now, let me ask you, if you are reading A, B, C, D, E, F, you get to t. How do you read it? You simply read it as what? T. Which means that this base t, this function t, is in its simplest form. Its simplest form as we are expected to know it. Just like you see it in alphabet. Anytime an alphabet is given to you in its simplest form, the way you see it in your ABCD, if you differentiate that alphabet with respect to itself, you will get 1. Which means for this, if I differentiate t with respect to t, I will get 1. Differentiate with respect to t, what that minor function t is. If you differentiate t alone, you are going to get 1. If it is x, let's assume it is 3x raised to power 3, for example, and then you are doing differentiate with respect to x, what that minor function is, x. dx is going to give you 1. So that's the idea. This is something you can always just memorize, put that in your mind. Although the differentiation can still be shown, but there is no need of wasting time. Like in the case of that t alone, if I give you t alone as a minor function, for us to get this part, differentiate that minor function. T alone as it is raised to power 1, which is the simplest form that t takes. If you are reading ABCD, that's just t if you get a t. If you convert it to mathematics stuff, t alone is raised to power 1. If I'm differentiating this guy now using power rule, it's going to be use the power 1 to multiply the base t, go to the power 1 and -1. Just this. Use the power, multiply the base, go to the power and minus 1. If you simplify this, you are going to get 1 times t raised to the power 0, because 1 minus 1 is 0. And then simplifying further, this will be 1 times 1, because t raised to the power 0 is 1. And 1 times 1 will give you 1. So even though I go ahead for this particular question now to do this part, because what I did to get 9t squared is this part, to differentiate the minor function, which is this t alone, is going to give me 1. 1 times this derivative will still leave me with this 9t squared. So what am I trying to say in essence? Anytime the minor function is in its simplest form, I repeat, anytime you are doing differentiation and you notice that I call the minor function, and that minor function is in its simplest form. And what is the simplest form of a variable? The form that you see it if you are reading ABCD. Simply put, that guy raised to power 1. If you differentiate it, the answer will still give you 1. Okay, let's move on. So come to this and then use the power, multiply the base, go to the power and subtract 1. 2 times 2t will give you 4t. If you go to the power and subtract 1, you will get 1. Are you following, right? This thing I did by using this to multiply the base, I've actually done the differentiation. Once again, for this 2t squared, I have done the derivative of the major function using the power to multiply, because that is what power rule say we should do. If you come to differentiate the minor function part, t alone, just like I explained, the minor function is just this t alone. If you differentiate it, you get 1. So that if you use that 1 to multiply the 4t, you still get 4t. So no need for that. Don't worry. This issue of going to differentiate the minor function, you will see it as I pick another question. We move on to the next one, which is minus 7t. Come to this 7t. Differentiate that t using the power. Look at t here. The power is what? 1. So if you repeat the same thing, use the power 1 times minus 7t. 1 times minus 7. Then go to the power of t and subtract 1. Look at what I'm talking about. We have minus 7t. We have to differentiate this guy. So it's going to be equal to, okay, let me even forget the minus I've already introduced. The power is 1. Use the 1 to multiply. 1 times 7. Go to the power of t and then subtract 1 from that power. If you simplify this, you get 1 times 7, t raised to the power 0. T raised to the power 0 is 1. 1 times 7 is 7. 7 times 1 will still give you what? 7. I have already told you that if you are differentiating out any alphabet and that alphabet is in its simplest form, this is the simplest form that t can take as an alphabet. If you differentiate it with respect to itself, you'll get 1. That 1 times 7 will give you 7. Finally, we come to this 3. Now, I have just a question for you because I don't have time to go into explaining why that guy is 0 for now. If you want to learn more, you can just take a lesson on it on this channel under full differentiation stuff, where I teach this stuff, step by step, the way it's meant to be. Remember here, we're just trying to make a summary in preparation for your exam. Look at this 3. It's a number. Does it have t there? Is there any t there? There is no t. Since it doesn't contain t that you are differentiating with respect to, if you differentiate this constant, this number, you get 0. And that is what you should always remember. If you differentiate any number, as long as that number is not multiplied by the alphabet you are differentiating, it's not multiplied by that alphabet, the derivative will give you 0. So this guy, if you differentiate it, gets to 0, kick it off. You have no business with it. We are done differentiating. So friends, just imagine what I did here. What is difficult in it? Is it for me to use the power, multiply the base, go to the power and minus 1? Come here, do the same thing. Use the power, multiply the base, go to the power minus 1. Come here, use the power, multiply the base, which I told you don't even need to punish yourself on that. For the t there, it's in its simplest form. Is that the difficult thing here? And you see, that is the differentiation. Very simple. I am done with that. Please, let's move on. So at t equal to minus 1, all you just have to do is dy dt is equal to, anywhere you see t, you fix minus 1. So this becomes 9 bracket, in place of t, you fix minus 1, you square it, plus 4 bracket, in place of t, you fix minus 1, then minus 7. So dy dt at t equal to, permit me to open bracket and write, at t equal to minus 1, dy dt will give you what? Let's simplify this guy. If you simplify this, you are going to get minus 1 squared is positive 1. Multiply by 9, you get 9. Come to this, 4 times minus 1 will give you minus 4, then minus 7. 9 minus 4 is 5. 5 minus 7 is minus 2. So we have gotten the answer of this. I wasted time here because this, okay, let's say the first question I'm solving in this for you guys. Not my first question on differentiation. I have solid works on calculus where I broke down this stuff 1 plus 1, and believe me, that's the truth. You can check it out yourself anyway, and then you assure yourself of what I'm saying. I wasted time here. As a matter of fact, if I were to be seated in an examination hall, and the same thing, even you as you're preparing to be seated to take this examination, questions like this, you don't even need to write anything on paper. With your good knowledge of basic arithmetics, you can work it out without even solving anything on paper. Simple as that. Look at it. 3 times this is 9. Then the power reduced by 1, 2. Fix minus 1 there. You're going to have 9 times minus 1 raised to power 2. Simplify that, you get your value there, which is 9. Come here, 2 times this is 4. Then the power here will become 1. In place of this t, put minus 1. You have 4 times minus 1, give you minus 4. 9 minus 4 is 5. Come here, differentiate this. The t will go off to 1. You know that 1 times minus 7 will give you minus 7. 5 minus 7 will give you minus 2. As simple as that. You can do this. The only challenge anybody will have when it comes to calculus, differentiation, integration, is if you refuse to respect basic arithmetics. You see this, your simple plus, minus, times, divide. If you neglect it, that is the only challenge you will get, you will experience, you will face when you are dealing with everything calculation. If you come to calculus, the same thing, because what you are doing is just plus, minus, times, divide. So that is one of the reasons why GMAETS 41 always respect and give serious attention to basic level of learning. Remember, GMAETS 41 has a special channel dedicated to our basic scholars. You guys can also benefit from it to help you speed up in your calculation skills. The name of the channel is GMAETS 41's Basic Class. You write GMAETS 41, then Basic Class. GMAETS 41 Basic Class. You can check it out later. Make sure you subscribe to that channel. There you have wonderful stuff on basic arithmetics and how you can work on your calculations faster. All right, we are done with this particular question. Let's move on to our second question, please. Gabriel, you're welcome. Sorry I'm late. I understand it's not easy. All right. So I am scared for my exams. You don't need to be scared. Do your best. However, being scared could also be as a result of not starting early to prepare, right? But all the same, the truth is, once you register for any exam, you have no choice. You have to do your best. But this is something I always advise students. Like for GMAETS 41, for example, I started preparing students on WAEC and JAMB on this professional exam since last year, I think around August, September. Yeah. And this year, once this set is done, the JAMB exam, for example, even WAEC is starting soon. JAMB is on the 25th, that's when it's kicking off. I'll take 1 month, 2 months break for those that's going to take JAMB and WAEC for next year, 2026. From August 2025, I will kick off the preparation. You see, if you know you are going to take an examination, don't wait. For example, if I know I will be a JAMB candidate, a WAEC candidate for next year, or there is any professional examination I'm going to take for next year, or even if I am in school already, I'm preparing for terminal examination, you mustn't wait until when timetable is out. You mustn't wait until 2 months to the exam. Start on time. Please. That will help to reduce any fear. The truth of the matter is that your examiners will not go to heaven and bring questions. It's not done. The exam questions are always within the limits of what you're expected to know. So early preparation can help to eliminate any fear. However, whatever the case is, let this time not be the time for anybody to entertain fear for the examination you're going for. Here in Nigeria, as the case is, these exams are stalling up fully from this month. I think I heard WAEC is kicking off soon. I don't know if it is before JAMB. Anyway, all the same, it's your business. Mine is to prepare, to coach, to train, to prove beyond reasonable doubt that these things, you guys can do it. And I have this confidence in you people. But as it stands, if anyone is entertaining fear of this exam coming up, please pray about it. Try to kick off that fear. Yeah, issue of prayer. Prayer cannot just automatically eliminate it because our God is not magical. You ought to have done the needful, what is expected. But why I just say pray about it is help yourself, kick off the fear. Just tell yourself, I will go in and do my best. Whatever is the outcome, accept it in good faith. If it leads to excellent results, kudos, that's good. That's what we're praying for. And that's what we are working for. Imagine in Nigeria now, the time is 10:56, almost 11 p.m. We are on now because we want the best. But if it happens that maybe you didn't start preparing early, there is a reason that set you back, just relax. Go for the exam, do your best. Whatever is the outcome, even if it means you have to recite for it, don't feel disappointed. Let me tell you, some of us, we sat for this exam. In fact, let me tell you guys, GMAS 41, I sat for JAMB 4 times. It doesn't really mean that I passed very well, though, but this is not the story I share for today because we are here for something. But what I'm trying to say in essence is, may nothing be a reason to set you back. Always do your best at any point in time. And remember to always start early in anything you want to do. See, this exam you are going for is the professional exam, normally covering 3-year scheme of work. Many students started preparing from just a few months ago. I mean, it's not ideal. So please, I am encouraging you, dear friend, who say that you are scared of the exam. Don't be scared. Don't be. Be positive. Then do your best. Do your best. You can never tell. You may still ace it. And for those that have been preparing, good. Keep the momentum going. Okay? Keep the momentum going. Now we have this next question I'd like us to solve. Meanwhile, from the options provided, option A is -1, option B is 1, option C is -2, option D is 2. So the correct option here is C, -2. All right, let us look at this particular question. Let's look at this question. Question number 2. We are given this to differentiate x squared minus 1 over x all raised to power 2. Differentiate this with respect. Permit me to abbreviate this with respect. It is usually abbreviated like this. WRT, with respect to x. Differentiate this function with respect to x. With respect to x. Differentiate this with respect to x. Then we have options there provided as you expect. Option A is 4x raised to power 3 minus 2 over x cubed. Option B is 4x raised to power 3 minus 2 plus 2 all over x cubed. Option C is 4x raised to power 3 minus 3x plus 2 over x. Option D is 4x to the power of 3 minus 4x minus 2 over x. Once you do the right thing, you will definitely get the correct answer, if the correct answer is there. Solution. We are differentiating this with respect to x. Now, if you look at this function, this is just like y equal to x squared minus 1 over x all raised to power 2. So y is equal to this function, right? If you look at this, this is a polynomial. Y. You have this whole thing here serving as your base. and it is carrying this power 2, a number. If you look at the base, they contain alphabets. Then the alphabet is carrying a number as power. So this is still polynomial. This is still what? Polynomial. Now we have to differentiate it. dy dx is equal to, remember for polynomial function, what do? Differentiate from the major. The major is that guy that helps us identify this as a power rule stuff, which of course is this 2. So you start by differentiating that, and remember the rule. Use the power to multiply the base. Go to the power and subtract 1. So if you do that for this guy, you are going to get 2 brackets x squared minus 1 over x. Then all raised to the power of, come to this and subtract 1. If you subtract 1 from 2, you will get 1 here. You will get 1. Anything raised to power 1 is that same thing. So no need of putting the 1. I'll remove it. Or should I leave it? Maybe let me leave it for you. Now that you've done this, you have not finished solving it. You are not done getting your answer yet. Remember I told you, once you use the power n to multiply the base, go to the power n minus 1. Next, you are going to differentiate the minor function called f of x, or f of whatever alphabet that is the independent variable. Here, if you notice, our f of x is this whole thing in brackets. Because if I still remind you of the standard, y is equal to f of x raised to the power of n, you will agree with me that our n here is 2. Look at that, the power of this base. The base, f of x, look at it, all these things in bracket, they make up the base. So our f of x is this x squared minus 1 over x. Now let me ask you, if you're reading your ABCD, and you get to all this thing about x, the way you read x, is it, if you're in A, B, C, D, E, F, G, H, I, J, you now come to x, you now pronounce it as x to the power of 2 minus 1x. Is that the way you read that alphabet? No. No. Which means what you have here, that x is no longer in its simplest form. The f of x, the minor function, is no longer in its simplest form. Therefore, you must differentiate it. You must differentiate this whole bracket. Everything inside this bracket. In this case, we didn't differentiate the t. I told you, because all these t, if you now pick the t here, you see that the t is in their simplest form. So we are going to proceed to now multiply this times, we'll now do that differentiate with respect to x, what the minor function is. Now this is the minor function, x squared minus 1 over 2. But let me show you something quickly before I differentiate that minor function. That term can be written as x squared. Then if you come to this term, 1 over x, anytime in differentiation you have a number all over an alphabet, please change that thing to negative index using indices law. 1 over x will be written as x raised to the power minus 1. Which means if I'm differentiating this thing now, this is what I'm differentiating, okay? Anytime you're handling differentiation, you have a number divided by the alphabet. Please convert that into a negative power. Therefore, we'll come over, let's differentiate now. Come to this x squared. Differentiate x squared. How do you differentiate? This is still a polynomial guy. Use the power, multiply the base, go to the power minus 1. If you do that, this will give you 2x. If you go to the power and subtract 1, you get 2 minus 1, which is 1. X raised to the power 1. X raised to the power 1 is still x. Now, let me ask you, in this case, do you need to differentiate this minor function here on its own, x only again? Do you need to? You have done 2 times the base, go to the power minus 1. Just like using n times f of x to the power of n minus 1. Do you still need to differentiate this x alone? Like doing differentiate with respect to x, whatever the base is. You don't need it here. If you do it for this question, you will still get times 1. Because this x alone is in its simplest form. Just like what I explained to you in the case of t. So if you don't need to differentiate it. Since if you differentiate the x alone, you will get 1. So no need. You have done the differentiation of this x squared. It's simply 2x. Then come to this guy. This is the same as x raised to the power minus 1. If you are differentiating this x raised to the power minus 1, what do? It follows the same procedure. It doesn't matter that the power is that minus. Use that power, multiply the base, go to the power and subtract 1. So this will be written as, look at x raised to the power minus 1. will give you minus 1. Minus 1 will come down times that base x. Then go to the power and minus 1 from it. The power already is minus 1, you know. So if you subtract minus 1 from this, you'll be getting minus 1, minus 1. Come here, minus 1. Use the power minus 1 to multiply the base. Look at it. Go to the power, which is minus 1. Subtract 1 from it. You'll get minus 2. Which means that if I differentiate 1 over x, I am going to get, let me use this shade of marker to step down that minus, this minus here, look at it. Then when I differentiated this, it gave me minus 1 times x will give you minus x. Then go to the power become minus 2. The power become what? Minus 2. I explained that already. Look at it. You have, once again, x to the power of minus 1 to differentiate is equal to minus 1, which is the power. Use it to multiply the base x. Go to the power, which is already minus 1. Subtract minus 1. Subtract 1 from it. If you simplify this, you get minus 1 times x is minus x. Minus 1 is minus 2. So look at it. Minus x raised to the power minus 2. That's the derivative. This is just simple mathematics, basic arithmetics. Like I said, imagine what I've been doing here is just times minus, times minus. Don't joke with your basic arithmetics. You see, from my many years of experience, what I have found out is challenges that many students usually have when it comes to calculation subjects. It's not even because about it. It's not because of the topic itself. Their problem is from foundational maths, basic arithmetics. It was also part of the reasons why, even though that GMAETS for the one's basic class was built specifically with our scholars in basic level of learning in mind, I built that because the truth of the matter is the birth of GMAETS for the one really came as a result of my thought of wanting to give the best to our little ones coming up. Those in primary school, those in junior secondary school. But you know, as our God and helper would have it, as we are moving, I saw the further need to, you know, explore all the levels as the case might be. You guys need basic arithmetics. It will help you out to be fast in all this. When somebody is explaining it, you'll be understanding very well what the person is saying. Let's simplify. Anything raised to power 1 is that thing. So this bracket raised to power 1 is that bracket. That power 1 will go off. Permit me now to remove it. And whenever you have a bracket and the power of that bracket is 1, you can open up the bracket. So these two can multiply the things inside the bracket. 2 times x squared will give you 2x squared minus 2 times 1 over x will give you 2 over x. Then remember that this bracket is multiplying this bracket. Permit me to write this as 2x. And then this is minus minus, you get plus. Minus minus, you get what? Plus. X raised to the power minus 2 from the law of indices is the same as 1 over x to the power of 2. Negative index law. This one is not further maths. It's not calculus. It's general maths, right? Negative index. If I give you x to the power of minus a, the rule said take the reciprocal of the base. And reciprocal of anything is 1 over that thing. The base is x here, so it's going to be 1 over x. Then this power minus will change to positive. So that is what I've applied here. Minus times minus plus, then you work on this, 1 over x raised to power positive 2. All you now have to do is to open up this bracket. Open up this bracket. If you're opening up this bracket, what are you going to get? Simple. This times this. 2x squared times 2x will give you 4x cubed. Like I said, still basic arithmetics. 2x squared times 1 over x squared. Let me show you the working at least for peace to reign. But I really don't need it. If I'm using this 2x squared to multiply 1 over x squared, this x squared will cancel this x squared. So I'll be left with 2 alone. But just let me show you. 2x squared times this 1 over x squared. 2x squared times 1, numerator to numerator. That's how you multiply. You get plus 2x squared all over x squared. Then this 2x squared has done its work. I've used it to multiply this term. So the next, I'll use minus 2 over x to multiply. Minus 2 over x times this 2x. Once again, this x and this x will cancel. Minus 2 times 2 will give you minus 4. But I'll still show you the working. As I am doing all these things for you people, don't take it after this. Oh, thank God you are never finished. You have to go back to your basic mathematics. Very important. Spike up the network of your brain in calculation aspect. Improve that skill, and then it's going to help you a lot. So that all this showing of works and other things, you avoid them in examination hall. You don't need it. Minus 2 over x times this numerator will multiply this numerator. You get minus 4x all over this denominator x. Then minus 2 over x times 1 over x squared. Minus 2 will multiply this plus 1. You get minus 2. Then the denominators x times x squared will give you x cubed. You cannot do your simplification. You cannot do your what? Simplification. Watch. This x squared and x squared will cancel. This x and x will cancel. When they cancel your dy dx, please take notes. Take notes. Take note. Let me say this before somebody there will now say, hey, them talk they said that calculus is difficult. Hey guys, stop saying that. This is where I did the differentiation. This is the calculus. This level, this is where I finished what differentiation really is for this question. Calculus. Everything I am doing here is just ordinary simplification, which you meet right from JSS 2. Yeah, that is grade 8. That's in grade 7, grade 8, depending on the school. Another thing, as a matter of fact, some pupils in primary school, grade 5, grade 6, they do this. At least I can boast to tell you there is a child that trained in this already. He's in grade 8 as at now. And when I trained him on this, he was in grade 4 or 5. So it's just all about basic maths. So having cancelled this, you now have 2 minus 4. 2 minus 4 will give you minus 2. 2 minus 4 will give you what? Minus 2. So this becomes 4x raised to power 3 minus 2. Because you have 2 here, you have minus 4 minus 2. Then this is minus 2 over x cubed. And this, of course, is the answer. This is the answer. 4x cubed minus 2 over x cubed. You can still write it like this anyway. You can still arrange it like, say, or this is 4x cubed. Bring this minus 2 over x cubed first if you want. Then shift this minus 2 behind. They are the same thing. Now listen as I dictate the options. Listen as I dictate the options. Option A, 4x cubed minus 2 over x cubed. 4x cubed minus 2 over x cubed. Minus 2 over x cubed. And of course, option A is the correct answer. Option B, we have other stuff like 4x cubed minus 2 plus 2 over x cubed. It's not plus. You can see this is minus. This is 2 over x cubed. And then other useless options anyway. No time to waste. The correct answer is option A. Please, dear friends, in all these things I solved here, where did I do my dy dx itself? That thing that is called calculus, that is called differentiation, where did I do it? Just the first step. Just the first step. You know, this thing I wrote here just to copy. I just copied out the question. You don't need to copy it out. You could have just started differentiating straight, looking at your screen. This is the calculus here. Every other thing below here is not calculus. It's just basic simplification. And the knowledge of your basic arithmetics guide you there. Obia Julie is a primary school. Okay, yeah, that's the truth. That's the truth. I am telling you, this is primary school pupils from primary 5. They learn expansion, opening up of bracket. That's what I did here now. Remove bracket. Grade 5, don't they do it? I taught at that level of education, so I know what I'm saying. At least by God's grace, I have had experience teaching at basic level of learning primary school. I taught in secondary school for many years. And I have the opportunity running tutorials for advanced students, university students in different schools. So whenever I say some things, I'm not saying it just to encourage you people. No, I'm saying, yeah, to encourage you, no argument, but I'm just saying the facts. So it's not left for each and every one of you, dear friends, to activate as you follow up with the GMAETS for the one's firepower, academic firepower, in seeing that I put you guys through. Like I said, to make all these things interesting, make sure you improve your basic maths knowledge. That is it. And I guess what you're seeing here is should motivate you to now start looking into your younger ones. Encourage them. Let them improve their knowledge in calculation skill. The world now has gone technological, and for us to survive in it, our brain should be conducting fire when it comes to reasoning. This can only be possible from the foundation. It's not all these things you have pupils like here in Nigeria doing 13, 14 subjects. Gosh, this is something else. We have to limit this and focus on the most important subjects. You can help your younger ones in that. While schools do their own, you can help your younger ones. You see, maths, don't play. English, don't play with it. Then after these two guys are established, because these are the two brain developing subjects, other ones can now be attached. Yeah, basic general science, very important also, because a scholar, a child needs to know about the scientific world, stuff like that. Anyway, I always like encouraging people so that we avoid this cycle of complaint on these academic stuffs that are not difficult. I know you friends will pick this challenge, this advice, and do the needful. Now let us look at this next question. This next question, we have this. All right, if y equal to 2x plus 1 to the power of 3, if y is equal to this guy, find dy dx. I hope this did not cut off from the screen. Let me check. Okay, it really did not, but it went off a bit. Let me see if I can adjust the camera so that just a little. Just a little. Good. So please explain number 2 again. You see, this is a video lesson, right? So usually one of the good things again is that at the end of this, a copy of this video will be made available, right? So you can still come back and rewatch where you control me. You can pause. Okay, what did he say here? Grasp that point, move on again and stuff. Then make good notes, good summary note. But a quick one anyway. This is the function given to us. It is a power rule function, polynomial. So to differentiate, use the power, start from that outside power to multiply this function of x, the base. Go to the power and subtract 1. Look at it. 2 times this whole bracket, 2 times that whole bracket. Go to the power and subtract 1. You'll be left with power 1. Power 1. Anything raised power 1, that power 1 will go off. It's that same thing. Then times, go to the bracket and differentiate that minor function, that function of x. If you want to differentiate this, come to x squared, differentiate it. It's still polynomial, power rule. Use the power to multiply the base, 2 times x. Go to the power, subtract 1. That will give you 2x. To differentiate this 1 over x, I told you convert it to x raised power minus 1, the inverse, right? Then that x raised power minus 1, look at it, showed you use the minus 1 to multiply the base. Remember, this thing is following the same pattern. Use power, multiply base, go to the power, minus 1 from it. So this is going to be minus 1 times the base x. Then go to the power, which is originally minus 1, subtract 1 from it. Subtract 1 from it. If you work on this, minus 1 as power will give you minus 2. Minus 1 times the x raised power minus 2 will give you minus x to the power of minus 2. That's how I got this. Then using indices law, this guy you are seeing here is the same as minus 1 over x squared. That's the interpretation. Look at it. But this minus eventually changed to plus because here we had the follow come minus from the question. And when I differentiated 1 over x alone, it produced its own minus. So minus times minus gives you plus. Then open up this bracket. That is expansion. You can work on that yourself. I'll come back to it later to see how I did the expansion. And this thing I did showing the work, I actually wasted time. You really don't need it. Solution on this, we want to solve this, right? We're going to solve it. If I solve, I'll dictate the options. So once again, observe that this is power rule. So what do? To get your dy dx, use the power to multiply the base. This is the guide that helps us to know that this whole thing is a polynomial term or powers of something. So you start by differentiating from the major function, which is the power. The guide that helps you to identify that this is a polynomial function. So 3 times the base, we give you 3 brackets 2x plus 1. Go to the power and subtract 1. If you subtract 1 from 3, you get 2. Now I have done the first guide. This issue of use the power n to multiply the base f of x, then go to the power and subtract 1. Look at it. And I told you that whenever you do this, you've not actually gotten your answer. It depends on the function. If the f of x, the base, the variable, is not in its simplest form, if it is not in its simplest form, you must do this part. Differentiate with respect to x, whatever that minor function is, you must do it. And look at this. These are minor function, the function of x. Is this thing in its simplest form of x? If you are reading your ABC there, you get to the letter x. Do you read it as 2x plus 1? That is not the way you read it. The simplest form of x is x only like that, not 2x plus 1. Therefore, this minor function f of x is not in its simplest form. And because it is not in its simplest form, this x here is not in its simplest form, you have to differentiate with respect to x what you have here. Let's do that and see. So I will come to this now and then differentiate times. I'll come to this 2x and differentiate the 2x. If you want to differentiate this 2x with respect to x, what do? Simply differentiate that x now, right? Only that x. That x there is power 1. That x there is power 1. X raised power 1 is x. It is in its simplest form, that x alone. And so if you differentiate x alone, you get 1. 1 times 2 will give you 2. Remember to differentiate. Use the power, multiply the base, go to the power and subtract 1. If you do it for this x, you get 1 there. 1 times 2 will give you 2. So this is times 2. Then plus a waste of time. I'll still wipe it off. Plus, come to this and differentiate this. Remember, if you differentiate 2x alone, I said you're going to get 2. If you differentiate 1, look at this one. Does it contain the x you are differentiating? Is there any x here attached to this one? No. So this is a pure constant, the number. And I told you from the first question we solved, if you differentiate the constant, you get 0. It goes off. Like I said, a waste of time. Just for you to see, that is why I did that. So I'm going to wipe it off. If you differentiate this one alone, you get 0 because it does not contain the alphabet you are differentiating. Good. Now we are done. This thing I did here is the calculus, is the differentiation. Any other thing I do below is basic arithmetics, normal simplification. Now watch. This bracket 3 cannot open it. 3 cannot open this bracket. This is something that some of us still have challenge with. But as you're doing this, I'm trying to explain, even though I should be as fast as anything, but I want you guys to get this fact very well. I know when I'll speed up, no problem. Let's still move on. This bracket cannot open because this power is not 1. Bracket can only be opened if the power of the bracket is 1. The power of this bracket is 2. It's not 1. So these 3 cannot open up this bracket. Therefore, what you're left to doing is using this 3 to multiply this 2. 3 times this bracket raised to power 2 times this 2. It doesn't matter how you arrange it. You can have 3 times 2 or 2 times 3 as the case may be. And 3 times 2 will give you 6. So this becomes 6 bracket 2x plus 1 raised to power 2. This is the value of the dy dx there. You can listen to the options as I read. Option A, 6 brackets 2x plus 1 raised to power 2. 6 brackets 2x plus 1 raised to power 2. 2x plus 1, you close the bracket, then raised to power 2. Option B, 3, open bracket, 2x plus 1, close the bracket, raised to power 2. Option C, 6, open bracket, 2x plus 1, close your bracket. Option D, 3, open bracket, 2x plus 1, close your bracket. So you see clearly that the correct option is 6 bracket 2x plus 1, close the bracket, power 2. That's option A. So option A is correct. Now we have solved a couple of questions that follow power rule. Joy, you're welcome to the class. Gift, thank you very much for wishing me more strength. I appreciate that. Okay, guys, let us look at other questions. No time. Say we are still meant to look at integration and matrices. I should be resting by now. Like I said, the GMAETS, academic firepower, is on and on high alert. Unleashing them gradually. So let's keep going. Now look at this one. I'm going to pick some questions randomly now. I'm going to pick some questions randomly. Let me see if I can find a one on trigonometry. I should. Let's see. Let's see. I've really not seen anyone on the on trig function on the. Okay, no, I think I've seen. That's good. So let's deal with this particular question. Question 4. You are given this. If y equal to sine x, the examiner says you should find d2y d squared x. d2y d squared x. Find d2y d squared x. If y equal to sine x, find this guy, d2y d squared x. Find it. Now this guy you are seeing here means you should differentiate this function 2 times. That's the meaning. dy dx is first order derivative, which means differentiate once. d2y d squared x means differentiate 2 times. Now listen, let me read out the options provided here. Option A, 2 cos x minus x sine x. Option B, sine x plus x. Sine x plus x cos x. Option B is sine x plus x cos x. Option C is sine x minus x cos x. Option D is x sine x minus 2 cos x. Like I said, we have to differentiate these 2 times. That's the meaning of d2y d squared x. This thing means second order derivative. Differentiate that function 2 times. So first, we have to get our dy dx, first derivative of this. First differentiation of this. If I give you sine x and you differentiate it, what will you get? I said that already, standard derivative of sine. Remember when I introduced the standard, I started with something like this. And I told you to get your dy dx, differentiate the minor function d dx, differentiate the minor function with respect to x, then times differentiate the major function. I told you if you differentiate sine, it will change to cos. Then in front of the cos, you write the original minor function. That's what I told you. So yeah, we're going to apply that. It's very simple. So once you know those standards, the problem is solved. This is y equal to sine x. If you compare this with this, you'll agree with me that our x is this f of x. So the minor function is x. The major function sine remains sine. So we're going to differentiate the minor function, differentiate with respect to x, whatever the minor function f of x is. In this case, f of x is x alone. Then after that times, you differentiate the major function sine. Now, if you differentiate this x alone, what will you get? You'll get 1. Because this x alone is in its simplest form. And I told you if you differentiate any variable in its simplest form with respect to itself, you'll get 1. So if you differentiate this x, you get 1. There is no need of punishing yourself in that. Just go straight and differentiate your sine. Because if you differentiate x and you get 1, 1 times differentiate sine now to get cos. 1 times that cos will still give you cos. So simply put, no time to waste. If you differentiate sine x, you simply get cos x. If you differentiate sine x, you simply get what? Cos x. This is the standard I used. If you differentiate sine x, you get what I said, cos x. Now remember, we have to differentiate 2 times. This is the first derivative. It implies that to now get the second derivative, the 2y d squared x, you differentiated the first one, you got this. So to get the second derivative, you are not differentiating this. You are not differentiating this. So let's differentiate cos x and see. If you differentiate cos x, you're going to get minus sine x. If you differentiate cos x alone, you get minus sine x. I've explained that. Differentiate the minor function, which is x. It is in its simplest form. So you differentiate, you get 1. 1 times derivative of cos. If you differentiate cos, you get minus sine. And if you write that minus sign, you must write in front of the sign the original minor function. So 1 times this will still give you this guy. If you differentiate cos, you get minus sine x. So that is the answer. That's the second derivative of this guy. If you differentiate sine 2 times, you'll get this. The first derivative of the sine will give you cos x, and then the second derivative will give you minus sine x. I don't know the kind of options that were provided here anyway, because it seems like the answer is not there. So this is what we've got. Option A is 2 cos x minus x sine x. That's not the answer. Option B is sine x plus x. That's not the answer. Plus x cos x rather. Then option C is sine x minus x cos x. That's not the answer. Option D is x sine x minus 2 cos x. That is not the answer. The answer of this guy is not in this option. I am suspecting, likely, I am suspecting that maybe the original question here is something like this. I'm suspecting that maybe the original question is y equal to sine square x. That's what I'm thinking of, sine square x. That is what this thing could be. And maybe I could solve this thing with sine square x, and it's possible we'll get the options that they have there. Right? We'll differentiate this, sine square x. But for this is the answer. And like I said, the answer is not in the options provided. I'm going to wipe this. Finish up. Is there any question? Is network disturbing you guys? Let me see. What if we integrate sine x? If you integrate sine x, you're going to get minus cos x. If you differentiate sine x, you're going to get minus cos x. All right. Devan Shukuma, you wrote minus sine x. So I don't know what that minus sine x is. Are you trying to say that's the answer of this? If that is what you mean, then you are correct. But I say in the options provided, I don't know why that option is not correct. The options they gave, they are not correct. If you differentiate sine x twice, you are going to get that thing that I obtained. Let's move on, please, to our next question. Like I said, anyway, before I do this particular one, I think I'll have to, that is before I solve what I suspect to have been the question here. What I suspect to have been the question here, sine square, that is square sine x. Before I solve that, I would like us to at least encounter a question of on product rule. Okay, let us look at this question. We have this one. Question number 5. If y equal to x sine x, if y equal to x sine x, find dy dx when x equal to pi over 2. When x equal to pi over 2. Good. Find dy dx when x equal to pi over 2. Solution. Please remember you can support GMAETS 41. Very important. I've always talked about that. Send GMAETS 41 is super chat, super thanks, super sticker. You can become a channel member also. So if we differentiate x sine x, then we'll get option A. I guess it was a typographical error. Yeah, that's what I'm saying. I am assuming that that thing is typographical error. But I just felt that maybe it could be square sine x that they want to differentiate. But if you differentiate that guy, it will produce 2 sine x cos x, which if you get 2 sine x cos x, you can differentiate it using product rule. I just felt, I was like, maybe that is it. But it's a good thing I think you said if you differentiate x sine x, you're going to get option A. So good enough. I just had to solve what I saw in the question. Now we have x sine x here. So let us differentiate and see whether we can get one of that answers they have here. We are asked to find dy dx when x is equal to pi over 2. But y alone is x sine x. So how do we get dy dx? If you look at this function, observe very well. This is y equal to x times sine x. That's the function given to us. Y equal to x times sine x. These two functions are being multiplied. Product. Remember, when two functions are being multiplied and you have to differentiate, you use product rule. Where I told you, keep this constant, differentiate this, multiply them, then plus, reverse the process. Keep this constant now, differentiate this, multiply them. That's the product rule. So coming here, we can get dy dx without waste of time, no time. Remember, I told you, do not memorize that, a kind of in y equal to uv, dy dx is u dv ds plus v du. You don't need it. Just look at this. Y is equal to x times sine x. Simple. Keep x constant, differentiate sine x, plus keep sine x constant, differentiate this x. Since these two guys are being multiplied, you must use product rule. So we go, this is equal to keep x constant, then differentiate sine x. If you differentiate sine x, you will get cos x. You'll get what? Cos x. So let me use another shade of marker. Keep x constant, differentiate sine x. If you differentiate sine x, you get cos x. Then plus, this time around, reverse the procedure. Keep sine x constant now, and then differentiate x. If you differentiate x, you get 1. Remember, this is standing on its own. Please. This value you got here cannot multiply this x in front of the sign. Normally, this 1 is meant to multiply from behind. If you are multiplying a trig function by another thing, that another thing normally multiplies from the back of that trig function. That other thing cannot multiply the angle in front of that trig function. I'm saying this because, although for this guy being 1 times this will still give you that sine x. So nobody should think that I use the 1 to multiply the x in that case. No. Here it's going to be 1 times sine x. Very important for you to take note of this. So that in case this thing were to be maybe 2, and you now think that you're using the 2 to multiply this x so as to get sine 2x. No, it's wrong. That 2 will multiply from back. So it will now become 2 sine x. All right, so this is the product rule, as simple as it is. And my dear friends, this is the calculus, this is the dy dx. The way you differentiate two things when they are being multiplied. How simple this could be. Right? Keep this constant, differentiate this. Keep this constant, differentiate this. So your only problem with this differentiation is for you to know the standard derivative of those functions, then know the rules. And I told you there are 2 major rules you need. Product rule and quotient rule. You see all the differentiation I've been doing. That I differentiate this guy to get, what is it called, sine x or what? This one, I differentiate to get this result. What I use, the procedure is actually chain rule. But I am saying that you don't need that chain rule. The major minor differentiation concept from GMAETS 41 here makes this very simple for you. So we only have product and quotient rule. That other rule I told you, sum and difference rule. That was what we applied to the first question we solved. When do you apply sum and difference rule? 2 or more functions are being added or subtracted. Differentiate each of them one after the other separately. That is the sum and difference rule. So there's nothing there. The main rule in differentiation for me is product and chain rule. Product, you use it when 2 things are being multiplied. And that's what I did here. Keep this constant, differentiate this, plus keep this constant, differentiate this. We're going to meet quotient rule as we move on. So if you simplify this guy, your dy dx will be equal to x times cos x will give you x cos x. Take note, this x will not go and multiply this x here to give you x squared. No, it's not done. I've just told you that about it here. to only multiply from behind. 1 times sine x will give you sine x. So this is the result of that differentiation. But I think we are asked to find the value of dy dx at x equal to pi over 2. So I don't need to forget that. If it was just, okay, get dy dx, this is where we stop, right? Now, at x equal to pi over 2, what is the meaning of this pi over 2? When you are dealing with trigonometric function, when you are dealing with trig function, and pi appears in front of that trig function, let's say sine pi, cos pi over 5, whatever. Since that pi appears in front of the sine, the cos, the tan, or whatever trig function, that pi has an angular value in degree, and it is equal to 180 degrees. I guess for my JAMB students, or the GMAETS 41's JAMB student, I've actually talked about this in physics. We met it, I guess, under wave, progressive wave equation. I explained something like that for you guys. Besides, on this channel, you have all these works already there. Under circular motion, I guess you would see that also. So let us move on, please. This is equal to 180 over 2. So let me write it, which will give you 90 degrees. So pi over 2, this pi over 2 is in unit of radian. Pi alone is 180 degrees. Divided by 2, you get 90. So x is equal to 90 degrees. Therefore, dy dx at x equal to pi over 2 or 90 degrees will now be equal to, wherever you see x, you fix 90 degrees. You fix 90 degrees. But remember, that is if the x appears in front of the trig function. If the x is not in front of trig function, please, it won't be taken as 90 degrees. It won't be taken as that 180. It will not. It will not. So watch this now. Watch this. I'm sorry that I had to convert this to 90 degrees directly, because I was just looking at everything in front of this sine cos xx. But look at this x. This x, you won't fix 90 degrees there. You won't. It's going to be maintained pi over 2. It's going to use the normal value of pi, which is 22 over 7. The approximate value of pi, 22 over 7 or 3.142. Reason, because this x is not in front. It's not an angle that the cos or sine, the trig function, is carrying. So this is going to be, anyway, you've heard as I explained it. You have heard. So I'll come here in place of this x, I am fixing pi over 2. Take note. This pi here is 22 over 7 or 3.142. Then cos, this x now, because it is in front of this cos, is going to be 90. Then plus sine. This x is in front of this sine. Is an angle that this trig function is carrying. So it's going to be 90. And so we now get, watch. Cos 90 is equal to 0. This cos 90 here will give you 0. So that 0 times pi over 2 is equal to 0. Plus sine 90 is 1. Sine 90 degrees is 1. So you now conclude dy dx is equal to 1. That's the answer at this point, x over 2. Remember what I explained. If you are fixing anything pi in front of a trig function, that pi will be taken to be 180 degrees. So in this case of pi over 2, it will be 90 degrees if that angle, that pi stuff, is in front of a trig function. But if you are substituting pi for something that is not in front of trig function, is not in front of it, please, that pi will not be taken as 180 degrees. Rather, that pi will be taken as our normal pi, which is approximately 22 over 7 or 3.142. The options provided here, let's see, we just differentiated x, sine x at pi over 2. Let's see, option A, pi over 2. Option B, 1. Option C, minus 1. Option D, pi over minus 2. So the correct answer is 1, which is option B. We are moving on. in Bolu, you know, this is a live class, so and I'm trying to minimize time and other things. Don't worry, time will come. I'll be hosting classes in which the live class will be okay. Give students questions they solve. I have all those things in perspective. For now that I'm trying to teach, solve these questions for you guys. Giving you a question and waiting for all of you to try might just take unnecessary time. We'll stage special classes for such subsequently, and you'll get details on when that class holds. Meanwhile, I saw your answer. You got one here, and that is fantastic. Keep it up. And I think you've been contributing to the class. You've been contributing to the class, and that's good. Keep it up. So we move on to the next question we have here. Let us take this question and see. Let us take this question. Look at it. I've got something like this. Question number 6. This could likely be the last question I would like us to consider here. So I will move on to at least integration. Find the derivative of sine theta over cos theta. Find the derivative of sine theta over cos theta. Find the derivative of sine theta over cos theta. Now we have the options. Option A, square sec theta. Option B, tan theta cosec theta. Option C, cosec theta sec theta. Option D, square cosec theta. Those are the options provided. Now look at the function given to us, please. If you look at the function, this is sine theta over cos theta. And because this is sine theta over cos theta, you see clearly that the function is in quotient form. It has numerator and denominator. It's in fraction form. Whenever you have two functions and they are being divided, you must apply quotient rule formula in the solving process. And you remember quotient rule, right? Keep the denominator constant, differentiate the numerator, minus, keep the numerator constant, differentiate the denominator, then divide everything by square of the denominator. So let us apply it here and see. This is the function, so we go dy dx, keep the denominator constant cos theta, then I'm going to differentiate the numerator. If I differentiate the numerator, it will change to cos theta. Differentiate sine theta, you get cos theta. That theta is just like all this x of a thing. So here, this is not going to be dy dx. It's going to be dy d theta because the function depends on theta. Are you getting me? This is just like y equal to sine theta over cos theta. Y depends on theta. So you'll be writing this as you want to find out how y changes if theta is changing. How does changes in theta affect y? Dy d theta. That's the meaning of that. If I depend on you or you depend on me. You depend on me now, yeah. You depend on me. So I'll try to teach you now. Imagine I host a live class and for some reason, I am unable to handle that class because you depend on me on the live class. Maybe if you come over online, you are waiting, you're not seeing me. What is going to happen? You will likely tune out. Maybe if you wait for like there about 15 to 30 minutes, are you sure this is going to hold? I don't think. You tune out. You will log out. Why? I have affected you. Something happened that affected me. So there's a change, perhaps in my activities, and the thing affected you. So we are trying to find out how, since you depend on me, how does my change affect you? And then differentiation will now say, du d me. That is just what we are doing here. And you see, calculus is very wonderful in life. When you come to the field of invention, calculus, vector, matrix, these three guys, they are absolutely important. Now, I have kept the denominator constant and differentiated the numerator. Look at what I got. Then minus, you now reverse the process. Keep the denominator constant, sine theta, and then differentiate the denominator. Keep numerator constant and differentiate the denominator. If you differentiate cos theta, you get minus sine theta. Now that I've finished this, I will divide everything by square of cos theta. That is square of the denominator. Square of the denominator is written like this. Cos theta, you see, all square. But hey, the way we present this basically is, this is written as cos square cos theta. This is the way we write it, okay? So you take note. I won't write it this way for you. I'll use the standard form it's being presented. So this is going to be square cos theta. Square cos theta. Remember, I gave you the rule. I say keep denominator constant, differentiate numerator, minus keep numerator constant, differentiate denominator, all over square the denominator. So what I have to do is to simplify this. If you multiply this and this, you get square cos theta. You get square cos theta because this is cos theta all raised to power 2. Sin theta times minus sin theta, the minus will come out and multiply this minus, you get plus. Then sin theta times sin theta will give you square sin theta. Square sin theta. Square sin theta. Then divide everything by square cos theta. And now let me tell you something. Under trigonometry, on this channel, if you go to the playlist, under Math 101 / Math 102, right? That's elementary mathematics. If you go through, or even in this live session, as in the live stream section of GMAETS 41's video lesson, there is this special video I released on trigonometric identity. Trig identity. There is something we call Pythagorean identity. If I tell you to get the square of sine of an angle plus the square of cos of the same angle, I repeat, square of sine of an angle plus square of cos of an angle, the answer is equal to 1. And that's what we have here. Square cos of an angle plus square sine of an angle is equal to 1. So this thing you are seeing here is simply 1 over square cos theta. 1 over what? Square cos theta. We refer to this. This is 1. There are 3 Pythagorean identities. This is one of them. Square of cos of an angle plus square of sine of an angle. This can come here if you want. This go there. Square of sine of an angle plus square of sine of cos of the same angle is always 1. Then divide by cos theta all squared, or square cos theta. Now, are you aware that 1 over cos theta is equal to sec theta? If you are not aware, you have seen it. On this channel, you have all these things. Under trig identity, I've worked on this. 1 divided by cos theta is equal to sec theta. Therefore, 1 divided by square cos theta will give you square sec theta. 1 over cos is sec. So 1 over square cos will give you square sec. Just fix the angle in front of it. And that's the answer. Therefore, dy dx or dy d theta. Dy d theta for that question given to us, if you differentiate this, you are going to get square sec theta. All right, the options we have here, option A, square sec theta, which of course is the answer. Option B is tan theta cosec theta, and then other useless options here. The correct option is A, square sec theta. All right, so I'm glad I joined this class. Straightforward explanation. God bless you, sir. Thank you very much, Brahms Prod. You are welcome to join the class. Thank you. So I think this is sufficient for differentiation. We've done a lot of things on differentiation. Let us move on to integration, please. Let's move on to integration. Let's move on to integration. We don't have time to waste. We are looking at integration now. At least let's see if we can take the class to 2 hours. This is already 1 hour 44 minutes. Oh my gosh. Which means we will not be able to handle matrices and determinants in this class, but no problem. We'll schedule a class for it. Tomorrow, we should be looking at tomorrow. Yeah. So let us say perhaps tomorrow morning, can I be able to run a class tomorrow morning? My petrol will not be enough to carry that. But let's see, all the same, maybe later in the evening. But that later in the evening, I should be looking at, can I still run maths? I'll get you guys informed. To know more about our classes, the updates, please contact GMAETS 41. Send a message to this number on WhatsApp. Request kindly to be added to our general WhatsApp group. In that group, you will get updates about our classes. If you are sending a message to this contact to be added to our general group, please indicate your name, where you are contacting us from, and your level of studies. Are you in secondary school, that is high school, or are you in advanced level, say 100 level, 200 level, you know? Indicate, please, so that we'll know where to add you to the group that you should belong to. Okay, so we are done with this. Let us move on. I think, please, I will wipe off the board. I'll wipe off the whole board because I am shifting attention into integration now. I'm shifting attention into integration. I'm shifting attention into what? Integration. So be fast. Finish up what is on the board. I hope network is not disturbing on my device here. Don't know what's happening. All right. So I'm wiping this, please. I said we are moving on to integration. Integration is simply reverse of differentiation. Integration is reverse of differentiation. I am supposed to give you standard integrals, but I don't have that time for that now. I've told you can slide through the GMAETS 41's playlist on this channel, Math 101, Math 102 playlist. Scroll through, you will see video lessons that deals with this thing step by step. I'll just focus on solving questions on integration, then we'll see we could just close for today. Then make arrangement for matrices and determinant. So let us look at some things we have under integration. Like I said, integration is reverse of differentiation. I would only give you the general approach to integration. If I give you integral of a function or function of x, for example, say you should integrate with respect to x. Let us assume I gave you something like this. This is read as, listen and follow through. Integrate the function of x with respect to x. I take that again. Integrate the function of x with respect to x. In this case, anyway, permit me to use g here and use f. I want to maintain f of x as our minor function. In this case, this is our f of x. So let this be integrate the function of x with respect to x. Once again, integrate the function of x with respect to x. Now this is the major function, major, and this is the minor. So the general definition to integration is simply integrate the major function, which is integrate this g, the major function. That guy you pronounce first. Integrate it. And once you integrate it, remember to write in front of it the original minor function. And this is the original minor function, f of x. I want us to maintain it. Write in front of it this f of x. Then divide everything by, what I'm giving to you is the standard integral definition using the major minor concept. Integrate the major function. Then come over here, the minor function, differentiate it. That minor function will come as denominator. Differentiate with respect to x, whatever the minor function is. Once you do this, you put plus c. Add your constant. Add your what? Constant. I hope you're still on. It seems like, okay, you can follow, right? That's good. It's differentiation part of calculus or statistics. It's part of calculus. It's part of calculus. Don't know what's happening to this device. I can't seem to stream from here. Is it that my data has been exhausted from this device? I don't know. But the camera is still on. I felt that network is disturbing. Let me see. But the camera is still in progress. So we move on. The streaming device should be there. I'll get data further. Okay, let's see. Let me check my data balance. Free. So please, you want to take note of this. So if you are given any function in a standard form, you want to take note of this. I am going to give you a quick example. Like for polynomial function, if I give you y equal to f of x raised to power n, I say you should integrate this with respect to x. The major function is this power, because this is what helps us to know that this is in polynomial form, powers of a variable. The minor function is this f of x. So what do? Integrate from the major function. That is going to give you, to integrate polynomial function, you do the opposite of differentiation. Remember, in differentiation, we use the power to multiply the base, then went to the power and subtract 1. In the case of integration, you will add 1 to the power, which is write the original minor function, go to the power, add 1, divide by the new power. But you are not done. Remember, you must differentiate the minor function. You must differentiate the minor function. What I did there is opposite of what you saw in differentiation. Once again, remember, in differentiation, you use the power to multiply. In integration, you are going to use the power to divide. But before using the power to divide, you must have added 1 to the power first. Because in differentiation, you subtracted 1 from the power last. So in integration, you're going to add 1 to the power first, and then divide instead of multiplying. Since in differentiation, you multiply by the power. So in integration, you're going to divide by the power for polynomial function. But like I said, following this standard, you are meant to differentiate the minor function. So the minor function, which is f of x, will come to the denominator. It will multiply this guy here, which is differentiate with respect to x, whatever the minor function is, and then add plus c. This is a polynomial function. Now let me show you for this trig function, at least only for sine. If I give you y equal to integral of sine f of x, I say you should integrate sine with respect to x. What will be the standard integral following this? It's simple. This is the major function because sine helps us to know that this is a trigonometric function. The minor function is still our f of x. So you have to integrate sine. And if you integrate sine, what will you get? If you integrate sine, you will get minus cos. Minus cos. Then remember to write in front of this cos the original minor function. Like I said, when you integrate the major function, it must go with the original minor function. Look at it here. When I integrate the major function by adding 1 in polynomial case, see the minor function was written there. So I have integrated the major function sine. It gave me minus cos, then you write the minor function. You are not done. Divide this by, you differentiate the minor function. Differentiate with respect to x, whatever the minor function is. Like I told you in the case of differentiation, you have to wait for the examiner to give you what the minor function is, and then you do the differentiation. So you put plus c. I have integrated this. That c there is called constant of integration. It is an arbitrary constant. You can use any alphabet you want as a constant. It doesn't concern anybody. Is that okay? It's just that most times you prefer using C, 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 C. You can see K as well too. You can see K, you can see A. The choice is yours or the examiner's choice. Whatever constant alphabet is being used, you just put it for them. Okay, guys, so we are done with this. I think the data on this device has been exhausted. I just checked. See, I'm spending a lot for you guys, spending a lot of resources to ensure I give you the best. So please, you can always support GMAETS for the one. In the chat section of this live stream, you have, just by the right, you have the, I think you have the currency icon. If you click on the currency icon there, just in that chat section, by your right, if you click on the currency icon, you would see super sticker, super chat, membership. Please click on it, and the packages that will appear. Support GMAETS 41 with whatever that is convenient for you. The data in this device has been exhausted. But I think the camera is rolling, and that's okay. Let's keep it going. Let's keep it going. All right. So I will do a little check what is happening through the camera. I use this device to stream and know what is happening at that end. But the data is off there, and because we have to move on. So we move on to our very first question. I've shown you the standard you need. With this thing, you see what I am teaching you, what GMAETS 41 is doing for you in differentiation, in integration, I am helping you to eliminate the stress in that thing, that stuff that is called function of function. You meet it in differentiation, you meet it in integration. That stuff really makes students to develop this, I don't want to use hatred, but it makes students not to like, not to appreciate calculus. But the truth is that the function of function stuff can be dealt with using all these standards, right? Major, minor. And with that, it helps you to avoid any stress in chain rule, because this covers this. Like what I did here is reversal of chain rule. Let's take our very first question here, please. Question number 1. Under integration, we are asked, please, before we take question, I want to tell you something in case I meet something like that. There are some type of integration given to you, and we will have what we call limits. Something will be written here, either a number, another number will be written on top. We call the number written here lower limit, the one written on top upper limit. In such integration, you don't put this plus c, you don't put it. That type of integration is called finite integral, because the examiner has done condition you integrate from this point to this point. So when you are done solving, you apply the integral limit. You don't need to put plus constant of integration. This constant of integration is used if the integration is infinite integral. There is nothing like limit. But the point is that in finite integral, where you have limit, you must still do the integration first before you apply the limit. So I have my very first question here. This question I have here, you are asked to integrate with respect to x. Okay, so evaluate rather. You are asked to evaluate integral sine 2x dx. Integrate integral sine 2x dx. Option A, minus 1 over 2 cos 2x of cos 2x then plus k. That k is the constant of integration the examiner used here. Option B, minus 2 minus cos 2x plus k. Minus cos 2x plus k. Option C, cos 2x plus k. Option D, 1 over 2 cos 2x plus k. These are the options provided. So how do we solve this? This is 1 plus 1. From the question you observe, this is major function, mj. And then 2x is minor function, mn. Can always combine, right? So I'm going to integrate the major function, then divided by, I'll differentiate the minor function. And this reminds me, please, do not be tempted to want to learn integration without differentiation. Integration depends on differentiation. In every integration, you have a differentiation in it. So you are expected to have mastered differentiation very well. You go through differentiation before dealing with integration. I'm saying this because there are some persons, maybe they feel they can deal with integration without differentiation. No, you will get into trouble. So integral sine 2x is equal to, I am integrating with respect to x. So I will integrate sine. If you integrate sine, it will change to minus cos. All right, so you have minus cos. In front of that cos, you write the original minor function. You write the original minor function. Then all over, differentiate the minor function. So I give you 2x, and I tell you to differentiate 2x. Just differentiate the x there. Anything you get, use it to multiply the 2. We just concluded differentiation so you can follow through. So if you differentiate 2x, you're going to get 2. Write that derivative of the minor function in the denominator. Then put plus. K was used as constant of integration. Now this is the same as minus 1 over 2. Because this over 2, bring up minus 1. Then cos 2x plus k. And this, of course, is the solution. Very simple. From the options provided, option A is minus 1 over 2 cos 2x plus k, and that is, of course, the correct option. Option A is correct. Now we have this next question. The next question we are asked to integrate. Question 2. Let's see, where is it? Integrate cos 4x dx. Find integral of this. Then we have the option A, 3 over 4 sine 4x plus k. Option B, minus 1 over 4 sine 4x plus k. Option C, 3 over 4 sine 4x plus k. Option D, 1 over 4 sine 4x plus k. Once again, it's a simple question. Solution: identify your major and your minor. Integrate the major divided by differentiate the minor. That's all. The major function here is cos. If you integrate cos, you get sine. Why? In differentiation, if you differentiate sine, you will get cos. So if you integrate that cos, you will get sine exactly. Look at this one we solved, that we integrated sine and it gave us minus cos. Why? Why did it give us that? Under differentiation, if you differentiate cos, it will give you minus sine. So if you integrate minus sine, you should get back the cos. But nobody will usually give you minus sine to integrate. Rather, they will give you sine alone to integrate. So that minus will transfer to that of cos first. So you go to the side of cos. So that if you are integrating sine, the minus will now go to the cos you are going to get. I repeat that again. In differentiation, if you differentiate cos, you get minus sine. So if you integrate minus sine, you are expected to get cos. Therefore, if you are integrating only sine alone, that minus there with that sign would go to that of the side of cos. So that if you integrate sine, you now get minus cos. Look at it. So that's why we had minus cos here as the integral of sine. In the case of cos, we know that from differentiation, if you differentiate sine, only positive sine, you get positive cos. So if you integrate positive cos, it will give you back the positive sine. So we move on. Integral of this guy. So we have integral cos 4x will be equal to cos 4x dx will be equal to integrate the major function cos. You will get sine 4x, sine of the original minor function, divided by differentiate 4x. If you differentiate 4x, you will get 4. Then put your constant of integration. This is still the same as, or over 4 is the same as 1 over 4. Then sine 4x plus k. And from the options provided, option A is 3 over 4 sine 4x plus k. Option B is minus 1 over 4 sine 4x plus k. Option C is 3 over 4 sine 4x plus k. Option D is 1 over 4 sine 4x plus k. And I guess that's what I have there. 1 over 4 sine 4x plus k. Option D is correct. Okay, we are moving. Let us take seemingly what I would consider as the last question for today. This is already past 12 midnight. And of course, we have done something good. We'll complete this in our next class. But let's take one more question. Let's take one more question. Or should I make it 2 more questions? I'll make it 2 because this one I want to solve, question 3, is still a straightforward something. I would like us to solve one that has limits in it. But I just met this. You're asked to evaluate integral square sec theta d theta. Evaluate this. Evaluate integral square sec theta d theta. So you are going to integrate square sec theta with respect to theta. And this is just 1 plus 1. The answer is tan theta. There is nothing to do there. So you can see how simple calculus is. Yeah, somebody can say this is basic calculus. Forget about that. There is nothing like higher calculus. There is nothing like what higher calculus. Yeah, because whatever you meet at whatever higher level as the case might be is based on this foundation. In higher calculus, is it that they would change? They will now tell you that if you're integrating square sec theta, it will now give you cosec theta. Is that what they're going to tell you? No, it can never change. If you integrate square sec theta, you will still get tan theta. Am I communicating? Solution. Integral sec square sec theta d theta. The answer, like I said, is tan theta. Why? In differentiation, if you differentiate tan, it will give you square sec. So, okay, differentiate tan theta, you get square sec theta. So, if you integrate that square sec theta, it will give you back tan theta. So, without solving anything, the answer is simply tan theta plus our constant. Let me use k also. Now, listen to the options provided. Option A, sec theta tan theta plus k. Option B, tan theta plus k, which is the answer. Option C is 2 sec theta plus k. Option D, another useless option, sec theta plus k. So the correct option, like I said, is option B, tan theta plus k. So B is correct. Okay, guys, we shall pick really our last question now. Question number 4. Let me see one that I would really have us to deal with. Let us deal with this guy. Okay, permit me to search out something a bit better. There is nothing so tough in all these JAMB question and other things anyway. Nothing really so tough. Nothing really so tough. They are just straightforward. They're just straightforward. Look at this guy, please. Although I'm not going to solve it, I'll just tell you something. Integrate 1 over x plus cos x. Integrate this guy with respect to x. Because of this plus, you will integrate each of them separately. Integrate 1 over x on its own. Integrate cos x on its own. And if you integrate 1 over x, you will get ln x. You get what? Ln x. Yeah, ln x. Because remember, in differentiation, if you differentiate ln something, the standard derivative of ln is 1 over. That is what I said, 1 over. Standard differentiation of ln function is 1 over what is in front of that ln. So if I have 1 over something and I'm integrating 1 over that something, that term should be raised to power 1. That term should be raised to power 1. So integral of 1 over this x raised to power 1 will give you ln x to give you back the ln function. Then integrate cos x. If you integrate cos x, you will get sine x. Okay, get sine x. Okay, let us look at this question. I've got no choice. I'll just bring out what we have here. We are asked to evaluate, determine. This is how they present the question. Determine integral 0 to pi over 2 of minus 2 cos x minus 2 cos x dx. Evaluate that term on the board. Then we have options here. Let's see. Evaluate the integral minus 2 cos x dx from the limit 0 to pi over 2 as given on the board. Option A is minus 2. Option B is minus 1 over 2. Option C is minus 3. Option D is minus 3 over 2. I hope this did not cut off from screen. Let me check to be sure. It's almost off, so I have to make a little adjustment. Good. So I've adjusted it, and we are going to just solve this so that we can go and sleep. Let's go and rest for tomorrow. Remember, like I told you, I'll be meeting you morning, evening. I'll try, let's say tomorrow, maybe between the hour of 8 to 9, before I attend to my physical JAMB class, right? 8 to 9. Let's see if we can work on matrices. Because in the evening, tomorrow evening, or is it tomorrow evening or later evening, we're already into a new day. We should be looking at physics. Okay, so this. Solution. We are given integral with the limit 0 to pi over 2 of minus 2 cos x dx. Now rewrite this tail. Listen, if you have a constant number multiplying, and simply if you have to integrate constant, the constant comes out of the integral sign. So this is the same as 2 integral 0 to pi over 2 cos x. Please, this is minus 2, so the minus will come out, minus 2 will come out. Then you now integrate simply cos x with respect to x. I repeat, to integrate constant, normally the constant will come out of the integral sign. It is said you don't integrate constant as it is, right? It will come out. It will remain. It will survive. Reason, in differentiation, if you differentiate a constant, it destroys that constant to 0. That constant will disappear. In integration, the constant will be brought back. It will be left. It will be allowed to survive. Because integration is antiderivative. It's opposite of differentiation. Please, so that's why this minus 2 came out of the integral sign. Then you're now left with cos x to integrate. If you integrate cos x, what will you get? You will simply get sine x. Reason. Under differentiation, you differentiate sine x to get cos x. You will differentiate positive sine to get positive cos. So if you integrate positive cos, it will give you back positive sine. That is what we had here, did that. So this is equal to minus 2. Then I'll open a square bracket. Integral of cos x, I said, is going to give you sine x. Close the bracket. You are not going to write plus constant of integration. No, you wouldn't put that constant of integration. Because you have limit here, you have to apply the limit. And the limit, you write it, lower limit and then upper limit, pi over 2. This is the way you write that. Are you following? I think I want to squeeze this part. Let me manage this part of the board so that all the solution would enter there. So it's simple. Do your normal integration. Do your normal integration, which is what I've shown you here. Minus 2 will come out normally because it's a constant, it's a number. You don't integrate it. So you now have cos x. Integrate cos x, you get sine x. Then because this is finite integral, it has limit. You have to apply the limit. You don't need to put any plus k. No. These ones, they are infinite integral, no limit. So once you get your answer, you put a constant to show that you are here to get the boundary of integration. Here, the boundary of integration has been set for you, 0 to pi over 2. So what do? Wherever you see x in the answer of the integration you got, the answer of the integration we got is sine x. So wherever you see x, you integrated with respect to x, because this dx is telling you integrate only the function of x. So when I integrated this cos x, the function of x, it gave me sine x. Wherever I see that x, I will fix this limit, starting with the upper limit first. So this is equal to, you keep this minus 2 the way it is, then open bracket, sine x. In place of this x, fix pi over 2. And I told you that pi over 2 is equal to 90 degrees if it appears in front of a trig function. I said that, I think it was under differentiation I said that. Pi is 180 degrees if it is appearing in front of trig function. So pi over 2 in front of this sign would give you 180 over 2. So we go. This becomes sine. In place of this x, you put pi over 2, and pi over 2 is 180 over 2, which is 90. Are you following? I have fixed the upper limit, pi over 2, which is, in place of this x, sine x becomes sine pi over 2. Because the pi is in front of the sign, it will be 180 over 2. 180 over 2 is 90. That is the upper limit. I've fixed it. Then minus, you fix lower limit. Go back again to that answer of the integration you got, which was sine x. Sine, in place of x, you fix lower limit. And that lower limit is 0. That lower limit is 0. You can see that. So that is how you apply your limit. It's simply upper limit minus lower limit. But what do? Fix upper limit first. Then minus, go back, fix lower limit. And then simplify whatever you have there. Okay, let me conclude here. So integral 0 to pi over 2 trying to manage this, of open bracket minus 2 cos x dx is equal to, let's simplify this. Sine 90 is 1. Sine 0 is 0. This thing is equal to 0. This one. Sine 0 is 0. Sine 90 is 1. 1 times sine 90, let me write it. This is sine 90 is equal to 1. So 1 minus 0 is 1. Minus 2 times 1 will give you minus 2. So the integral value given to us to determine with this limit is simply equal to minus 2. Answer. And here we've got the options provided. And think, where is the question? Where is the question? Where is the question? Where is the question? Good. I can't seem to find the question anymore. Please, this question come out. Where are you? Where are you? The limit from 0 to this minus cos. Where is this question, for crying out loud? Okay, let's see. All right, I've seen it. Determine the value of integral minus 2 cos x dx from the limit 0 to pi over 2. Option A, minus 2. Option B, minus 1 over 2. Option C, minus 3. Option D, minus 3 over 2. And here we got minus 2. So the correct option is option A. Option A is correct. Option A is the correct option. So guys, this is how far we can go today. At least we've done some wonderful stuff. Remember, for those going for JAMB, these questions we treated under differentiation and integration, they are within the range of what you should be expecting if the examiner's JAMB is testing you on calculus, differentiation and integration. Yeah. If you have any further question you encounter and you are finding it challenging rather, right? You're finding it challenging, just, you know what to do. The GMAETS is there. You have to become a member of GMAETS 41, can become a channel member. Then send a message to this contact on WhatsApp, request to be added to our WhatsApp group so that you can drop your requests. Request that, please, you have a challenge, so question, and I'll come online and deal with that for you, right? Become a channel member. Become a channel member, you just tap the join button, or just like I said, in the chat section of this particular live stream, but just in that chat section, you have the currency icon. If you click on it, you will see super chat, super sticker, membership. Become a channel member on platinum level. That is just 2,000 monthly, 2,000 naira monthly, 2,000 naira Nigerian currency monthly, right? So send a message to this and request to be added to our channel, to our WhatsApp group rather, so that you get information about how our classes, our online classes go. And you know, that's it. There's nothing. This is simple. However, for those in advanced level, 100 level, okay, you are going beyond this. You are going beyond this. And like I've said, all these works have already been treated 1+1 on this channel. Go to the GMAETS 41's mathematics playlist, Math 101, 102. You have these things. Every aspect of what you should know about calculus dealt with. We only focus on the aspect of JAMB as the case might be. For advanced level, you still need to go further beyond this. So tomorrow by 8 to 9, 8 a.m. to 9, is it tomorrow? I don't know. Today, later today, 8 a.m. to 9 o'clock a.m., I'll be solving questions on matrices and determinant. So make sure you are at alert. Stay tuned. Remember, for those going for JAMB and WAEC, you just have a few weeks to the exam. No time. This is time you have to work hard, do your final revisions and other things. And so you want to be up and doing. As I do my best for you, I'm not the one taking the exam. So I see no reason why you shouldn't be there. Like I said, always remember your support is needed and appreciated from GMAETS 41. And remain blessed in all of your efforts. Don't be scared of this. Do the needful. Make sure you connect to classes, you study, ask questions if you have, and that's it. Your exam questions will always come within the framework of what is required. So you have no reason to be scared. always make sure you keep preparing, you keep studying. So guys, I'll be seeing you later in the day. Like I said, we'll be dealing with matrices and determinants in the later part by 8 a.m. to 9 a.m. Then later by 8 or 9 p.m. we are going to look at thereabout physics, I guess. All the best and have a good night rest. I'll be going to bed also. So wish me a good night rest.